Kia ora, Year 12. This is the last excellence question from the integration paper. So the excellence questions in questions 1 and 2 I did at the very end of last year, just after the exam, because of student requests. I've left this one until now. So the worst part in this one is figuring out the limits, and then it's a proof question. We're given a couple of graphs here. The graph shows these two functions, so this one, and k is a constant greater than 1. So we have to show that the shaded area is this, and we're not given any information. So the first thing that we have to do is figure out what are these points here. This is clearly y equals k, and the curvy thing is y equals k e to the x squared, which is just k squared e to the 2x. So step 1 is going to be to figure out what these 2 points are here. And you can kind of see from looking that this looks like it's going to be 0, and that will fall out of what we do. So step 1 is to find the limits, and then we're going to look at the top function minus the bottom function. So we're going to have limit here, and then it'll be k squared e to the 2x minus k dx, and then off we go with our integration, and our goal is to get down to here. So it's actually not that bad. Right, so the first part is that y is equal to k e to the x squared, and y is equal to k. So we're going to solve k squared e to the 2x equals k. Let's have everything on one side. And now we're going to factorize out the k. That makes complete sense because we know that one of our limits looked like it was 0. And now you can see that appearing in the algebra. So either k is equal to 0 or k e to the 2x is equal to 1. E to the 2x is 1 over k, giving us, by taking logs of both sides, 2x is equal to the log of 1 over k. So x is equal to 1/2 times the log of 1 over k. Now you can leave it like that, or you can realize that this is equal to 1/2 of log of 1 minus log of k, and get the bottom limit as negative 1/2 log k. And that's what I did, but it will work out just fine if you work the whole way through with that one as well. So that means that the area that we're finding, the shaded area, is this: the limit between 0 and negative 1/2 log k of the top function, k squared e to the 2x, minus the bottom function, integrated with respect to x. Neither of these is too bad. The tricky work is just not mucking up our substitutions at the end. So let's integrate first and then go back and look at where we're trying to get to. Integrating this is going to give me k squared over 2 e to the 2x. Integrating this is going to give me minus kx. And my limits are these. And now we're really carefully going to substitute in. So I'll just give myself a wee bit more space. The first substitution, k squared on 2 e to the 0 minus 0 minus k squared on 2 times e to the 2x. So it's going to be negative 1/2 times 2 ln k minus k on 2, negative of this, so it's going to be a plus in here. Is that right? Yes, that's right. Okay, I'm just checking really carefully with my signs here. So I'm subtracting the bottom limit, and all I'm doing here is I'm taking this and I'm subbing it in here. That gives me k squared on 2 minus k squared on 2 e to the negative log k minus k on 2 log of k. One place we've got to be a wee bit careful is here. So don't jump too quickly to undoing the e and the log together. We can't do that until they're in exactly the right form. So we've got minus k squared on 2, and then this is e to the power of the log of k to the negative 1. And now that these are right next to each other, we can use the inverse property, and we can undo them. So we've got k squared on 2 minus k squared on 2 times k to the negative 1, which is 1 over k, minus k on 2 log of k. That gives us k squared on 2. I can feel some of you groaning at how slowly I'm doing this, but it's a show that question, right? So we are showing what we're doing. And now it's probably about time that I went back up and had a look at where I'm trying to get to, because I'm almost there. Right, so it's actually easier when you've got the exam paper in front of you. We're trying to get to this, right? We've got a k over 2 factor out the front and then a bunch of stuff. K minus 1 plus the log of 1 over k. So we can definitely see the k over 2 factor coming. K over 2, yes, minus 1, minus the log of k. Now, that is not what we've got. So hopefully you can see very easily how it almost is. Here we've got a minus log of k. We're going to do the opposite of what we did before. We've got k over 2 into k over 2 minus 1 plus the log of k to the power of negative 1, which gives me exactly the answer we're after. So there you go. I think quite a straightforward excellence question, as long as you keep your wits about you and you're really fluent with your skills at undoing logs and exponentials. If you've got any questions on the other 2 excellence problems, just send me an email, but those videos are up there already, so you can either find them on the playlist, or you can search on the channel, or you can use the website, because I've just posted them up there.